Today we'll start the second module of our analog and digital communications course. So in yesterday's class, we have discussed or we have revised about all the topics in the first module. And today, as I said, we'll start the second module. So what is the second module? The second module is angle modulation. Okay. So as I was saying in yesterday's class, I just have given a brief introduction about what is an angle modulation. Yes. If you take a sinusoidal carrier, let us say the carrier is C of t equal to some AC into cos omega ct plus theta naught, right? Let us say this is a sinusoidal carrier. Or I can say, since it is a sinusoidal carrier signal, this is unmodulated. Okay, so I'm still have not talked about modulation. So this is an unmodulated carrier signal, right? So just a sec, let me check whether it is recording. Yeah. So this is an unmodulated carrier, and here if you see, we have AC omega ct. Okay, so AC is the amplitude. Am I right? So maybe I'll just write this as C of t equal to AC into cos, something like some theta I of t. Okay, so what is theta I of t? What is AC here? AC is, what is AC? AC is the amplitude of unmodulated carrier, right? AC is amplitude of unmodulated carrier signal. Okay, what about this theta I of t? So actually this theta I of t is called as, this theta I of t is called as instantaneous angle, or I can say instantaneous phase angle of unmodulated carrier signal. Okay, so what is this theta I of t? This theta I of t, I have to write this as omega ct plus theta naught. Okay, so as I said, this theta I of t is called as instantaneous phase angle of unmodulated carrier signal. Okay, so what is theta of t? If you ask me what is theta I of t, I have to say that theta I of t is nothing but omega ct plus theta naught. Okay, now again, of course you know all these things, but I have to tell you what is omega c. Omega c is nothing but 2 pi into fc. So what is fc here? Fc is frequency of unmodulated carrier signal, right? So what are the units of what are the units of omega c, fc and all? Omega c units are radians per second, and fc units are hertz, or it is, I can say, per second. Yes or no? Because fc is equal to 1 by time, so the units of fc will be per second. Okay, so these are the units now. So the units of omega c. What is omega c, by the way? So omega c is actually, omega c? Omega c is angular frequency. Angular frequency. I know. I'm sure that you know all these things. These are the units. Okay. Yes. So omega c is called as an angular frequency, and it is actually written as 2 pi into fc. What is fc here? What is fc here? Fc is the frequency of the unmodulated carrier signal. Okay. And this theta I of t is called as instantaneous phase angle of the carrier signal. Okay. Now this is, you know, these are the characteristics of a general sinusoidal signal. Okay. So the signal that I've considered was AC into cos omega ct plus theta naught. Okay. So this is, you know, the pure signal, which means unmodulated signal. Okay. Now the point is, in the first module, what we have seen. In the first module, what we have seen was we had modulated, or in other words, we had changed AC. Okay. So in the module 1, what we did was AC was varied with respect to what? With respect to m of t, which means we have changed the amplitude of the carrier signal with respect to the message signal. Okay. Now, what are you going to do in the second module? Okay. So as I said in yesterday's class, in the second module, what are we going to do? In the second module, we are going to change this theta I of t with respect to m of t. Okay. So let me, you know, talk about that in detail. So if this relative position is, yeah. In module 2, what are we going to do is that theta I of t. What is theta I of t? Theta I of t is nothing but the instantaneous phase angle of the carrier signal. We are going to vary with respect to the message signal. By the way, what is m of t? M of t is message signal m of t. Okay. Now, if you know, if you just go back to the previous slide, theta I of t. What is theta I of t? Theta I of t. Sorry. Theta I of t we have written as omega ct plus theta naught. And one more thing, I did not write what is theta naught here. What is theta naught here? Theta naught is phase angle at time t equal to 0. Am I right? So what is theta naught t? It is phase angle at time t is equal to 0. Okay. Now let us see, you know, from here you can see that theta I of t is nothing but omega ct plus theta naught. Okay. So I can say this is the phase angle, or you can say that, you know, it is an initial phase angle, whatever. Okay, you can call it whatever, but it is, you know, t equal to 0 at t equal to 0. Okay. Now from this, you know, I'm talking about this, you know, theta I of t is nothing but omega ct plus theta naught. Let me no, let me just write that here. So theta I of t is equal to omega ct plus theta naught. Okay. Or I can, you know, write this one as 2 pi into fct plus theta naught. Okay. So this is our instantaneous phase angle of the carrier signal. Okay. Now the point is, how are we going to change this particular theta I of t? There are actually two ways. Okay. One way is I can actually change fc. Okay, such that, you know, or let me talk about the first one. The first in the first case, what are we going to do is this theta I of t, we are going to directly change this with respect to m of t. So in that case, what are we going to get is called as phase modulation. Okay, because we are directly changing the, guys, just a sec. Yeah. So one way is yeah. One way is you can directly change the phase of the carrier signal, and if that is the case, we call that modulation as phase modulation. Okay. And the second way is you change FC. What is FC? FC is FC is the frequency of the carrier signal, and when we change FC, I can say that if you change FC, what happens? Obviously, theta I of t will also change, and this this is called as frequency modulation. Frequency modulation. Okay. And in shorthand, we call this as PM, and this we call as a FM. But I want all of you to understand the following thing, that whether you change FC or you directly change theta I of t, ultimately the phase of the unmodulated carrier signal is definitely going to change. And hence, phase you can change in two ways. Okay. The first way is to directly change the phase with respect to the message signal, or you change the frequency of the uh, carrier signal in addition, sorry, with respect to the message signal. Both of them are changing with respect to message only. Okay. So this will also change the phase of the carrier signal. Am I clear? So any doubt so far? If you have any doubt so far, you can actually text me. Okay. Am I clear, guys? So what I can write is S of t is nothing but AC into cos theta I of t. Okay. So what is S of t? S of t is nothing but the angle modulated wave, angle modulated signal, or whatever signal can be written as S of t equal to AC into cos of theta I of t. Okay. Now again, this is what I have written there. Okay. Like what is theta I of t and what is AC, all these things I've written over there. Okay. So what is theta I of t? Theta I of t is so theta I of t is instantaneous uh, theta I of t is instantaneous phase angle, and AC is amplitude of unmodulated carrier signal. Unmodulated carrier signal. Okay. So the first one is instantaneous angle, okay, instantaneous phase angle of modulated signal. Of course, in this case, the amplitude of unmodulated carrier and it is same as the amplitude of the modulated carrier. Both are same. Okay. So I can maybe, write this one as like this. Okay. Because both are same. Because we are not going to change uh, anything with respect to the amplitude. We are just changing the angle of the unmodulated carrier signal such that the angle of the modulated signal will change with respect to the message signal. Okay. Now, if you see what is C of t here, what is C of t here? C of t is AC into cos 2 pi fct plus theta naught. So this is a unmodulated carrier signal. That's the unmodulated carrier signal. It is cos 2 pi fct plus theta naught. Okay. Now, I've already told you, like in the previous slide, that what is, yeah, this is what I was talking about. What is omega c here? Omega c is 2 pi fc, and what is fc? Fc is frequency. I have already talked about what are the units and all these things. Okay. The point is, what is the instantaneous frequency of the angle modulated? Let me take instantaneous instantaneous angular frequency of angle modulated signal is given by what? So what I'm asking, I am asking you this particular thing, instantaneous angular frequency. Okay, what do you mean by angular frequency? Angular frequency is like omega, right? So from this particular thing, okay, theta I of t, can you tell me what is the instantaneous angular frequency? So the instantaneous angular frequency, actually, the general form of theta I of t is what? Let me write it here. Theta I of t is, what is the general form? The general form of theta I of t is something like 2 pi fc t plus theta naught. Okay. So here we don't know whether we are going with phase modulation or frequency modulation. Okay. And hence I'll not write this one as fc, rather I'll just write this as fi. Okay. Or in simple words, what I will do is I'll just write theta of t as 2 pi f into t plus theta naught. Okay. Now, based on whether it is frequency modulation or phase modulation, the notations will change. That I'll discuss in a moment after this particular thing. Okay. So don't be confused. You just follow it, and after discussing these things again, I'll just quickly revise the things. Then it will be clear for you, right? So what is instantaneous angular frequency? It is omega I of t equal to, see, whenever we say angular frequency, it has to be omega, and since it is instantaneous, it is represented with I. Okay. And by the way, what is instantaneous? Instantaneous means at that time. Okay, at that time instant, which means, so it changes with respect to time. Okay, so at t equal to 1 second, the angular frequency value is one. It can be something like omega I of 1, and at t equal to second it will change, and so on, which means these two are not same. Okay, because they are all instantaneous values. As time changes, the values also will change. Okay, So what is omega I of t? How can I calculate omega I of t here? Okay, I can maybe, what I can do is I will write this as omega t plus theta naught. Can you tell me how to calculate omega from theta of t? It's simple. It is d by dt of theta I of t. Yes or no, guys? It is d by dt of theta I of t. Why? Because if you see here, I know only theta I of t here, right? Theta I of t is given to me because that is an angle modulated signal. So from the theta I of t, how can I calculate omega? This is the relation between theta and omega, right? That's the relation between theta and omega. So this theta of t is nothing but omega I. If you want, you can write I here. It's okay. So this theta I of t equal to omega I of t plus theta naught. Okay. And remember one thing, that theta naught is an initial phase angle which is not at all changing with respect to time. So theta naught is like a constant. Theta naught is always a constant. It will not change with respect to time. Okay. So initially it can be, you can think of theta naught as something like 30 degrees or 60 degrees or 33 degrees, something like that. Okay. Theta naught is a constant. It's not going to change with respect to time. Okay. Now from the theta I of t, how can I calculate omega I? Is you take theta I of t and differentiate it such that you will get omega I of t, right? It's simple. Just look at this particular expression, and from this you think of how to calculate omega I. So if I differentiate both sides with respect to time, what do I get in the left hand side? Left hand side I get d by dt of theta I of t, and right hand side, if I differentiate, let me write it. Left hand side I will be getting d by dt of theta I of t, and right hand side it's d by dt of omega I into t plus theta naught. Okay, let me say this is expression 1. Okay, so differentiate equation 1 with respect to time. Okay, now what do you get here? Left hand side I'll be writing the same thing as it is, d by dt of theta I of t equal to. Right hand side you can actually separate the terms, so it's d by dt of omega I t plus d by dt of theta naught, right? So left hand side it's d by dt of omega I of t is, I'll write the same thing as it is. Let me write it, d by dt of theta I of t equal to, so what is the differentiation of omega I into t? It's omega I plus, what is d by dt of theta naught? As I said previously, that theta naught is a constant, and then the differentiation with respect to time will give me 0. Okay, so which means I can simply ignore this 0, and you can see that omega I is nothing but d by dt of theta I of t, as we have written here. Okay, is that fine? Yes. um, Next one is, what is instantaneous frequency now? What we have seen previously is instantaneous angular frequency. Now let us see instantaneous frequency now. Instantaneous frequency of angle modulated wave. See, there is a reason for why we are discussing these things, because once if these things are defined, then later when we define frequency modulation, phase modulation, at that time we are going to use these things in order to derive the total angle of the angle modulated signal. Okay, so let us see what is instantaneous frequency of angle modulated signal. Okay, so is, what I'm going to do is, you just see this particular part alone. In order to do this, let us write What is omega I there? Let me rewrite the same expression that I have written here, expression 1. Okay. Let us consider the same expression. I'm not going to change anything. Theta I of t equal to omega I into t plus theta naught. So this is equation 1 in previous slide, right? So here what I'm going to do is I'm going to substitute what is omega I here. So it is 2 pi into fi into t plus theta naught. Okay. Now, can you tell me, or let us, instead of bringing the relation, let us do the following thing. Differentiate above equation with respect to time on both sides. So can you tell me what do you get on the left hand side? Left hand side, it's just differentiation, right? So it's d by dt of theta I of t equal to, right hand side, it's d by dt of 2 pi into fi into t plus theta naught. Okay. So left hand side, you just have it as it is for some time. It's d by dt. Okay. It's d by dt of 2 pi into fi into t plus d by dt of theta naught. Okay. Now, can you tell me what do we get for the first term? So what's the differentiation of 2 pi into fi into t? 2 pi is a constant, fi is also constant. So what I get is 2 pi into fi plus the next term is 0. Now from this, I can say that fi is equal to 1 by 2 pi into d by dt of theta I of t. Okay. So what is this? This is nothing but the instantaneous frequency of the angle modulated signal. Okay. So fi is nothing but the instantaneous, let me write it here, instantaneous frequency of angle modulated signal. So I'll again ask you, what do you mean by instantaneous? Instantaneous is like it's kind of a synonym for at that time instant. Okay. Instantaneous frequency of angle modulated signal. Okay. Yes. Now you can see that here that the theta I of t is instantaneous phase angle. So theta I of t is instantaneous phase angle of the modulated signal, or I can say of the angle modulated signal. Okay. And AC is nothing but amplitude of the modulated carrier signal or amplitude of the unmodulated carrier signal, whatever you can say. Both are same because we are not going to change the amplitude of the signal. Then this is kind of a thing that yes. So here theta I is called as instantaneous phase angle of the angle modulated signal, and omega I is instantaneous angular frequency, and fi is instantaneous frequency of the angle modulated signal. Okay. And you please carefully see the notations. Fc is frequency of the unmodulated carrier signal, whereas Fi is frequency of or instantaneous frequency of angle modulated signal. There is a difference between the two. Please carefully follow the notations. Okay. You can see here also I've written clearly that Fc. Okay. Fc is frequency of the unmodulated carrier signal. Okay. But the moment I say Fi, it is nothing but instantaneous frequency of, okay, you can see that here also. Fi is instantaneous frequency of angle modulated signal. Okay. So any doubts so far? You have any doubts so far? If you have, you can ask me. Okay. Uh, the class is going to end in 5 minutes or so. Okay. So should I start what is phase modulation, what is frequency modulation, or should I just quickly revise what we have seen today and I'll wind up? I think what I'll do is I'll just quickly tell you in 2 minutes that what we have discussed so far, and I'll stop for today. And in the next class, we'll see the definitions for phase modulation, frequency modulation, and what are the corresponding characteristics of those particular modulation schemes. Okay. Yes. So as I said, the second module is completely devoted to angle modulation. Yeah. The second module is completely devoted to angle modulation. Here